Hello and welcome to Data Migration Strategies for Dassault Systèmes 3DExperience. My name is Brian Scouten. I'm Director of Technical Pre-Sales for PROSTEP Inc. This is the second of four webinars we're doing with our 3DExperience Migration Week. And today we're going to go through different strategies for migration. So that entails what types of methods can be used for migration, how to best fit those different methods, for your organization, what might be involved within those, and then also how to organize a migration team as well. So with that, let's get going. This webinar and the four-part series of 3DExperience migration webinars that are happening this week are all sponsored by the COE. The COE, or Community of Experts of Dassault Systèmes Solutions, is a group that's coordinating best practices of utilizing DS products. So that could be CATIA or 3DX or Exolete or other products. They've got an annual conference. They host workshops and webinars like this one. They've got vendor partnerships and they're a volunteer organization. So if you're looking for doing volunteer work and working with others who are supporting these types of brands too, I'm sure they would be very much interested if you reached out and try and provide some support. They've got 7,000 members worldwide with 12 regional groups as well. The COE hosts its annual conference, the Co-Experience, this year in Dallas, Texas, May 13th through 16th. This year is going to be co-located with the MBSE Cyber Symposium, so probably see a lot of good crossover there, utilizing Dassault tools and then also best practices across Dassault with MBSE tools as well. And it's going to be a good networking experience. PROSTEP will be there as well, and we really look forward to it. So if you're interested, go to coe.org and take a look at the details, and you can register there. So there are two primary migration methodologies for PLM data. The first, and this is generally what we do, especially for smaller and medium-sized companies with PLM data, is an ETL, extract, transform, and load approach. The extract is how do you get the data out of the source system? So that could be data in directories. That could be data that's already managed within PLMs or multiple PLMs or PLM and ERP data that needs to be joined, all that type of stuff. The transform, that includes mapping of the metadata from all your source and combining that data to the target, as well as translation of data. Could be that you need to translate your CAD files or generate lightweight viewables or something like that while you're in the migration process. And the third, load, and that's just a clean import from the staging database to your system. You can do this in a one-time approach. So executing it all over a weekend, you shut down your old PLM on Friday, you run the E, T, and L parts over the weekend, and then you start within the new system on Monday. You can also do this in an initial load and delta update, so kind of a two-stage approach, where if there's not the performance there in order to meet the goals initially, you can spend time loading the data on the initial load, and then maybe just do the last month or 6 months of data within the Delta update in order to process all the data over a weekend and only move the users over that weekend. That then, is a little bit more coding, a little bit more processing and rehearsing, but then enables you to keep that tighter window. The second type is transactional, and this is defining smaller packages of data, and that could be programs of data. It could be different divisions that use data, but defining a smaller package and then moving that over time. And the idea behind a transactional is that you can use both systems at the same time in order to stabilize the new system, but then also to not move all the users all at once. When you move all the users at once, there's a big risk that the users don't know how to work with the system effectively, or it could slow down your business, right? And so being able to do this over time then enables you to slowly adopt the system. And this is good for larger scale enterprises. Problematic part is that you have to do this migration activity over a long time, keep alive both the systems, which might mean not just a one-way move, but a bi-directional type of integration so that you can enable parts that have been released in one system to reflect in the other and work to be done between both systems. So there's a little bit more effort there, and it's going to take longer in order to get into your new system, but with less risk overall. So as a strategy, you could approach this with either a big bang style migration that might be a week or a weekend to migrate all the users and all the data within one step. Or you could do an incremental type of migration or transactional migration that leaves both systems productive during the transition, and then move the data and move the users over time as your needs dictate. So let's dig in a little bit more to the transactional coexistence style of migration. So this is defining packages of data that might be projects, that could be programs, could be groups or divisions of data, and then processing that through an integration-like pipeline that you're building in order to keep data synchronized between the two systems. That pipeline needs to be bidirectional. The reason being, there's still going to be users within the old system and users in the new system that will have ownership of their data there. And understanding the business owner of the data is very important in this. And we're not just migrating the data itself, but we're also keeping in track what system currently has the ownership of that data. So if system A owns the data, then we need to synchronize it to system B. If system B owns the data, then we need to synchronize it then to system A if there's been updates to it. And then this enables you to work concurrently within both systems effectively. This is more difficult to develop. It's also slower to process. Generally, there's going to be not just one bulk import, so it's kind of a transactional stream that's based on real-time queues in order to process data, and then it has to be in operation all the time in order to keep the systems up to date. You do see more errors over time because of that. Unlike the ETL where you can process all the data within a rehearsal, and then go back and look at each data condition in bulk, you might stumble on these conditions because they haven't been tested out during this type of transactional coexistence. And we find that they're more easily controlled, those errors. You can reprocess data. It's not going to fail the migration, but you're going to run into them over a longer duration of time. And you also are going to have a team there that's available in order to maintain that. It's not as good performance-wise. It's hard to test because all those conditions for errors aren't always known up front. And I think it also enables users to stay within both systems. So sometimes it makes migration of users difficult because you've enabled them to use either one of the systems, and using new things isn't always as pleasant as the old ones. So let's look at an ETL style approach of a migration. Again, this is extracting data from various data sources into a staging database, doing a transform of that data. That could be just database mapping from one to another, or doing a binary conversion to create different CAD files, or maybe creating PDFs or something like that. And then loading the data into the new system. And you can do that either one time, or you could do that with an incremental load and a delta update. So the good things about an ETL is that you can test this out. You can test it out on 100% of the data. So you're never going to go into this situation where you don't know exactly what's going to happen during the migration, especially if you've done your testing very rigorously, corrected all those tiny little edge conditions, and 99.999% of the data is already known to be good in this migration process. So that's effectively where you're going to win here. It's easier to do than a transactional coexistence style migration because of that testing pattern, and you get high quality results from that. Now, where the risks lie is mainly in the user adoption. And that might not even be within the migration itself as a component of it, but in the system and the overall system performance, and the training and other things that go along with adopting a new system. So if you move all your users, let's say you have 50 users in the old system, you move them to the new system, that might be okay and manageable. But if you have 5,000 users in the old system and you are adopting a new one, then many of those users maybe didn't get fully trained on the system, don't understand the principles of how the mechanics of the system work, and that could really slow your business down. Or the whole system doesn't perform as it's expected because of an IT resource issue or something like that. That could then really grind your business to a halt. So big risk there, within the migration itself, really just because of the scale of this. Sometimes also, data gets out of sync. So if you're dealing with systems that already then have upstream or downstream integrations, you need to make sure that that data is all perfect, and then the motion of that data throughout your product life cycle is perfect as well. And understanding where data needs to be, in what formats, and with what metadata is very important within these types of migration, and sometimes that can get a little bit out of sync. ETL is also only good for one snapshot in time. So you could do that delta and update approach, but effectively that the initial load is one piece of time that you're moving in. The delta update is another piece of time. And if you're trying to do that over different cycles in order to package it, it can get out of sync. So this is really built for one-time repeatable test type of scenarios. So let's take a look a little bit about the PLM migration ETL process. So on the left-hand side, you've got your extract, and really those are the arrows that go between the data sources that you have there. Could be multiple data sources, PLM systems, ERP, or even directories and files and spreadsheets, things like that. In the middle, the transform, and so we've got two staging databases at the top. So when we export the data, we would load what we call our source database. And then once that's fully loaded, we run a transform on that to change that source into a target database. And then with that, also run the transforms if there is any translation on the binary data and the CAD data. Generate PDFs or JT, CGR, CreoView, other things like that. And then load the data on the right-hand side with those arrows. And so with those arrows that move between the E, the T, and the L, you're going to need maybe an export methodology. That could be direct to database. Generally, that's the fastest way to do it, but you have to reverse engineer things. And then there's also circumstances where you can get corrupt data. So that is especially evident with CAD data. Generally, CAD data with the PLM, when it's opened up, does some introspection, and then you can resolve other dependencies that are only really known in the file and not within the PLM database itself, so that all the dependencies can be loaded, and you kind of dynamically load those dependencies and save them out. Without that, you might miss files that are associated with it. You might also miss like renaming of the data, things like that. So you have to be careful about the APIs that you're using on export. On import, you also want to use a high-performant API in general, right? And the best case there. And we have packages of different APIs and connectors that are best suited for all these systems that are available for export and import as well. So when you're trying to develop a migration, especially an ETL migration, typically this is the work package model that we take. And it varies a little bit depending on what the migration might entail. But in general, we can use these different phases and work packages in order to define the migration pretty effectively. So the first phase is specification, and that's where we do an analysis of the data within the source systems. We try and do an understanding of what might be bad data initially so that we can start any cleanup efforts there. We test out processes for handling CAD, test out processes for any translation that you might have, script down, maybe not script, but go ahead and write down what the mapping is and the test cases. And then also gather the test data that you might need. So after that specification phase, we have a great understanding of what the migration is going to entail, and we're ready to develop the scripts in order to migrate the data. So within the second phase, design and build, and then also the testing phase, we'll install all the migration software, do the scripting, and do the tests that are needed in order to validate the scripts as well. And that might be smaller tests on a subset of data and validated by not the entire organization, but just by the migration group itself, so that we kind of keep that a small group to make sure that it's acceptable at that level. Now, once we're comfortable and we have the scripts developed that are going to migrate the entirety of the data, we're going to go into the rehearsal cycle, phase 3. In phase 3, we want at least 2 cycles, but maybe 3 or 4 that are data fully migrated from the source to the target. And we run this test on all the data to ensure that the quality is there, that the migration process can handle it all, or we need to go and maybe script some changes for these edge conditions, or go back and clean up data that doesn't get processed because there's bad data. But then from there, in the rehearsal cycle, we might get 95% of the data the first time, 99.9% of the data the second time, and 99.99% of the data the third time. And make sure it's effectively as near perfect as it can be. From there, we'll also have a great understanding of what the total performance metrics are for the production run of the migration, and then all the steps that we're following, in a productive migration, we should be also following within a rehearsal cycle. That might be, back up the source systems. That could be, shut down some users within the test systems. All the different rehearsal steps that need to be taken there from a production migration should be tested and executed within a rehearsal. That would then alleviate any possibility of failure because you can always fall back on those processes that have been well rehearsed. And then finally, phase 4, execute the production migration. And then throughout the production migration, there's that maybe an export, transform, and load. Validate each step, ensure that you've tested out the data, get all the reports that you've generated as part of the script process, that are qualifying the data that's been imported successfully. And then do some smoke tests and go live with the system. From there, there could be a couple of misses through the process. That 99.99%, you still have a couple of outliers. You're going to have to, maybe clean up a couple things after the migration, but you should have that well documented within the reports of the execution of the migration run, and know exactly what to target in order to go live, and go live with the system itself. So when you're developing the scripts that are needed to migrate data in an ETL style approach, generally, with the first sprint, you're doing the specification. But within sprint 2, the first focus of the development should be, how do I get the data out of the source systems, both the CAD data, the binary data, and the database data, and store that there. But typically, that's not as challenging as import or transformation. The second one is then, how do I then approach just the metadata? How do I create the changes and the BOM and the other PLM data within the system? So I already have the export that I can leverage from the first sprint. How do I push that data in? Second is then, how do I do the CAD data? And sometimes because of the different API processes that are required for CAD data export and import, or because you're doing translation or generating viewables or things like that, there's going to be special CAD handling. And so you can focus specifically on how do I then move the data from the source into the target with just CAD. And then I can then do all those edge conditions plus the CAD plus the BOM and changes within sprint 5 to kind of bundle it all together and test the system out. So it doesn't have to be broken down into sprints of duration. This could happen very quickly. If it's not a very complicated migration, or if it is more of a complicated migration that involves multiple exports from different systems, it could take more sprints, right? But generally, let's get your export down, then let's be able to migrate the metadata, then let's handle the CAD, and then the other edge conditions and the integration testing is definitely the way to go. So an effective process model in order to organize the people that go into a migration are to create what we call a migration office, as well as a migration technical solution team. And they could be the same people, but and many times they're not, right? Where the data migration office is going to be responsible for working with the business to understand the requirements of the migration. That might be multiple different divisions. They might have different requirements depending on the user community. They're helping define the mappings that go in there. Making sure that it's tested and accepted, the process of doing the migration, and make sure that the data is executed as it's supposed to. So a lot of testing that goes into that too. These are going to be a combination of source system SMEs, target system SMEs, and people that can work with the business. Also, if there's data cleanup involved, that's maybe release data that the migration can't handle, then might need to go back to the divisions and coordinate the cleanup of that data as well. On the technical solution team, this is a group of scripting experts who also know all the source system and target systems. So they're experts in migration of data for those systems. And then they can help with the specification, develop the scripts, do the testing of those scripts with the migration office, do the rehearsal cycle, so execute those rehearsals, also executed with the migration office, and in many times actually run the production migration as well. In some cases, the migration office team will execute the final migration, but a lot of times it's a coordinated effort between both teams. This is also a good way to separate so that you can efficiently work with us as PROSTEP, and we can be that technical solution team. And then coordinate with your team as the migration office. But we're also willing to take on most of the responsibility too, depending on the scope and scale of the migration. Another point to strategy, and this was included in the previous webinar, but I wanted to reiterate, is not everything needs to be migrated. So you can use like long-term archiving as a way to take that old data that you're only maybe going to use once in a while, and then put that in a repository where it can be permanently maintained, and then not be worried about upsaving it to the latest CAD, but using a neutral format like a STEP 242 format to keep that data effectively forever and not be burdened by the licensing or hardware constraints around what that might look like. And also separate those requirements, right, from what needs to be exported and taken from your old PLM and what needs to be put into the new system to move forward. And sometimes things like long-term archiving can be a component of that. But overall, think through those processes, make sure that you understand what needs to move forward, and scope it appropriately. And remember, PROSTEP is here to help. We've been doing migrations for a long time, a lot of successful migrations from many different systems. So we specialize in this cross-vendor, cross-domain type of migration and integration. We have software that's built in order to do this, that's commercial off the shelf, and good techniques on processing the data and understanding of source and target data. So, give us a call or send us an email. We would be happy to hear about your migration project and, maybe add some strategy to what you've got going on today. And with that, I thank you for attending our webinar today. And also special thanks to the COE for hosting this. We very much appreciate that partnership. And reach out. So again, I'm Brian Scouten. I'd be happy to hear about any of your migration projects and maybe can add some insight or value to that. So feel free to send an email or give us a call. Thanks.